However, there are some limitations to IR spectroscopy. For example, the radiation that are being emitted during the process can be damaging to humans, animals, and living organisms. These high frequencies can be a destruction process of organic and inorganic environments, which can result in diseases like vision loss and skin disease. Although IR spectroscopy is still used in student labs to identify materials, it is too outdated, and nowadays most chemists use nuclear magnetic resonance instead of IR spectroscopy. Real-life application. Infrared spectroscopy is a very important tool for astronomy. Using spectrometers, which are instruments that spread light out into wavelengths creating spectra, astronomers can study the emission and absorption line, which are fingerprints of atoms and molecules. You can learn about an object in space by studying a spectrum, such as composition, temperature, density, and its motion. Therefore, it will allow us to explore space more in depth. Did you know that infrared can help solve crimes? Using infrared in criminal investigation is not a complicated process. Any samples of evidence collected at the crime scene can be used under IR radiation. For example, if a segment of car paint was collected by an investigator, IR spectroscopy procedures to determine the composition of the paint and determine what vehicle processes that particular type of paint. Another example would be if a bullet shell was collected at the crime scene, the IR spectroscopy can be used to determine the composition of the metal. From that metal composition, the investigators form about what weapon took the shot and even which company manufactured the serum.
Forensic analysis is a time-consuming matter as the resources they need is not portable. It also damages the evidence if done wrong and only costs a lot of money. With the use of IR spectroscopy, Raman spectroscopy, and Fourier transform IR, forensic analysis becomes cheaper, faster, and these devices are portable. Kenneth W. Bush stated that when it comes to establishing time of death from skeletal remains, diffuse reflectance near IR just makes sense. This is because medical examiners have very little evidence to rely on to do a successful in-field examination, rather than if they were in a lab. Kenneth also noticed that finding the post-mortem interval, time elapsed after death, was also difficult to find, so himself and his team used near IR techniques to allow the medical team to find the post-mortem interval, and also found a way to make it portable. As a result of this forensic breakthrough, the time-consuming analysis was almost cut in half and justice officials could serve justice a lot faster. IR spectroscopy has many uses in the pharmacy industry, such as pill control, analysis of polymorphs, verification of raw material, and the homogeneity of mixing tablets. The foremost use of IRS is used for pill control. The FDA and other agencies use this technique as it is the fastest and cheapest way to do it, as the IRS instruments are suitable for a factory environment. Also, these agencies use IRS to check if the pill is contaminated. The second most used function of IRS is to verify raw materials to see if they can be used to make pills. Lastly, IRS is used to see the homogeneity of mixtures and mixing in tablets. In other words, to see if we can mix substances together to make pills rather than using trial and error methods. The biggest advantage of IRS in the pharmacy field is that there is no chemical waste and the sampling methods are non-destructive.
Created using Powtoon.